Hello, my name is Kyla Coimbra, and today I will be presenting a quick overview of our paper, Single Satellite Lunar Navigation via Doppler Shift Observables for the NASA Endurance Mission, which will be published in the ION Navigation Journal. As you may know, NASA's Artemis program aims to establish a permanent human presence on the Moon and into lunar space. To support future exploration, NASA and other organizations are developing autonomous rovers to study the lunar South Pole. One of these mission concepts is Endurance, which will be the first rover to traverse 2,000 kilometers on any extraterrestrial body. Its mission is to autonomously collect 12 samples along its traverse of the South Pole-Aitken basin. In order to properly geotag the samples, precise absolute localization of the rover is critical. So the key question of the study is, how can we localize lunar rovers with high accuracy while leveraging the existing infrastructure? Currently proposed methods, such as vision-based methods, are limited by poor lighting, map quality, and feature scarcity. Other methods rely on ground stations and multi-satellite solutions, which will not be available by early 2030s to support long-range rover missions. However, ESA's Lunar Pathfinder satellite, which is expected to launch by 2030, will be capable of communicating with the rover. We can leverage this opportunity by using the Doppler shift in its signal as a navigation observable. Thus, we introduce a navigation approach that relies solely on Doppler shift from a single satellite. By accumulating measurements over time while the rover remains stationary, our approach refines the rover's position over time using a weighted batch filter, achieving sub-10 meter level accuracy from just a single satellite. In the study, we assume the rover remains stationary at 3 key locations, which serve as test sites for evaluating our algorithm. The Lunar Pathfinder is in an elliptical lunar frozen orbit, and we use an initial epoch as shown here. We assume that the rover's initial positioning error is 100 meters in all 3 directions. We perform 100 Monte Carlo realizations of the batch filter per location of interest to validate our results. Through our analysis, we find that the mean and 99th percentile positioning error of 100 Monte Carlo realizations were able to localize the rover with the desired sub-10 meter level accuracy within 2 orbital periods of the Lunar Pathfinder. In our paper, we also performed sensitivity studies on the rover's clock type and ephemeris knowledge to better inform design decisions for the rover. Therefore, we demonstrate that utilizing opportunistic Doppler shift measurements as the only navigation observable is a feasible localization framework for the Endurance mission. For more details, please see our paper that is soon to be published in the Navigation Journal. The corresponding author on this work is Professor Grace Gao, and a link to the paper along with related projects is available on the NavLab website. Thank you very much for listening.